Hello everyone, welcome to In 5 Minutes. In this particular video, we will discuss the review of Z transform. Z transform is used for discrete time signals, which is studied in detail in the subject of signals and systems. Before we start discussing the subject of digital signal processing, it is very important to go through few important things that we have discussed in Z transform in that basic course of signals and system. That is simply because digital signal processing is all about the analysis of discrete signals and systems, and the transform that we use for discrete signals and discrete time systems for their analysis is the Z transform. So in many topics which we are going to discuss as a part of the syllabus of digital signal processing will require Z transform in some or the other form, especially the design of filters, which is one important module in digital signal processing. You may not have any direct questions from this particular topic because this is basically the review and we are just revising few things that we have studied before, so that whenever we come across the transform, we don't face any difficulty in understanding the topics of digital signal processing. So let us start, everyone. We will quickly revise Z transform. We will start with the definition of Z transform. If I consider a discrete time signal x of n, then its Z transform is defined as x of z, which is equal to summation x of n into z raised to minus n, where n is the variable of summation which goes from minus infinity to plus infinity. Because of the range of n which goes from minus infinity to plus infinity, this particular Z transform is called bilateral Z transform. So what is unilateral Z transform? In unilateral Z transform, n will start from 0 and go up to infinity. And it is very obvious that for most of the practical signals and systems, we will always start our variable n from 0. And hence, bilateral Z transform we study in theory, but when it comes to analysis of practical systems, we have to use unilateral transform. But then most of the things remains very much same. Few things change when we go to unilateral Z transform that we will discuss separately a little later. So right now let us go through the properties of Z transform, which is one very important part under Z transform. So please remember that Z transform is the transform used for discrete time signal. Let me quickly go through the significance of using transforms. Whenever it comes to analysis of systems, we can do analysis either in time domain. When we do analysis in time domain, we run into differential equations. So we will have to solve differential equations in order to do the analysis of systems. I can give you a simple example of electrical networks. When we do analysis of RC, RL circuits, in that case we run across differential equations. Now, often it becomes tedious to solve differential equations, especially when they are of higher order. And hence, we can change the domain in which we do the analysis. In transform domain, we first take the system in time domain, but we convert it to the transform domain. We do entire analysis in transform domain, and then we come back to the time domain by taking inverse or transform. So what is the advantage of doing this? The simple advantage is that the differential equation that we had in time domain gets converted to simple algebraic equation. So that's the strength of using transform domain approach. Every transform that you must have discussed before, Laplace transform for example for continuous signals and systems, and Z transform which we are discussing right now, we will look at couple of properties. It will convert differential equations to simple algebraic equations. Now we use the term differential equation only for analog systems. When it comes to discrete time system, we use a different term. Instead of differential equation, we call it difference equation. But we still have the same property offered by Z transform. The difference equations, which are similar to differential equations of analog systems, can be easily solved by converting them to respective algebraic equations in the transform domain. And that's the reason we use transform domain approach. And then we can study a lot of properties of system by staying in transform domain, which is a Z domain as of now.